Hello my dear friends, how are you all? I hope you all are fine. So you are very welcome in a lecture number 6 of circles. Okay, so I hope you will enjoy this lecture. So let's start without wasting the time. Yes, so here today we are going to discuss cyclic quadrilateral. Now what is cyclic quadrilateral? Okay, yes, so now in this we know that what is quadrilateral. Quadrilateral are those figures which having the four sides or four vertices. Okay, now let's suppose we have a quadrilateral A, B, C and D. Okay, now what is cyclic quadrilateral? So in cyclic quadrilateral, okay, if if all the vertices of the quadrilateral lie on the circle is called cyclic quadrilateral. Okay, now here is you can see A, B, C and D. These are the vertices of the quadrilateral, and these vertices lie on the circle. Here you can see that A, B, C, D, these points lie on the circle. So we can say that this is what? This is cyclic quadrilateral. This is cyclic quadrilateral. Okay, I hope you get this point. Okay, so we can write as a a quadrilateral, okay, is called a cyclic quadrilateral. Cyclic quadrilateral if all the vertices, if all the four vertices, okay, so if all the vertices lie on the circle. Okay, my dear friends, I hope you understand these things. And we know that angle A plus angle B plus angle C plus angle D. This is what? This is angle sum property of quadrilateral. So this will be is equals to 360 degree. This will be what? This will be equals to 360 degree. Okay, I hope you get this point. Now let's see the theorem based on this. So here is now theorem 10.10 states that the sum of either pair of opposite angles of a cyclic quadrilateral is 180 degree. This is what? 180 degree. Now according to this theorem, here is angle A plus angle C is equals to 180 degree in a cyclic quadrilateral. Okay, and angle D plus angle B is equals to 180 degree. It means the sum of either pair of opposite angles of cyclic quadrilateral is 180 degree. So we have to prove this. Okay, yes, so now first of all we have to write the given part. So what is? So A, B, C, D is a cyclic quadrilateral. Is a cyclic quadrilateral. Okay, with center at O. Got it? And here is we have to prove. Okay, we have to prove angle BAD plus angle BCD is equals to 180 degree. Means angle BAD, this angle, plus angle BCD is equals to 180 degree, and angle ABC plus angle ADC is equals to 180 degree. Okay, yes, so now let's prove. So here is, so this is the proof of this theorem. So now you can see in this cyclic quadrilateral, here is, let's draw the diagonals. So this is AC diagonal and this is BD diagonal. Okay, and let's suppose this is angle 1, angle 2, this is angle 3, angle 4, angle 5, angle 6, and this is angle 7 and angle 8. Okay, got it? Yes, so now here is in the different cases. Okay, now when chord AB, when we are taking chord AB, Okay, and we know that angles in the same segments are equal. It means here you can see this angle, angle 5 and angle 8 are equal. Angle 5 because they make the angles on the same segment. Here you can see. Okay, so we can say angle 5 is equals to angle 8. Okay, by the previous theorem. So here is we can write angles in same segment. Angle in same segment are equal. So here we can write angle 5 is equals to angle 8. Let's suppose this is equation number 1. And similarly in this you can say that when we take chord BC, this chord, so here is, so this angle and this angle 1 and angle 6 are equal because again angles in the same segments are equal. So the reason is same, so we can write angle 1 is equals to angle 6. Let's suppose this is equation number 2. Okay, similarly in this when we take DC as a chord, so the angles in the same segments are equal. So here is we can say that angle 2 is equals to angle 4. So here is angle 2 is equals to angle 4. Let's suppose this is equation number 3. This is equation number 3. Okay, and when we take AD as the chord, then here is this will make this like this. So we can say that angle 3 is equals to angle 7 because angle 3 is equals to angle 7 because angles in the same segment are equal. Let's suppose this is equation number 4. Got it, my dear friends? Okay, now by some angle property we know that angle A plus angle B plus angle C plus angle D, this is equals to 360 degree. By what? By angle sum property of quadrilateral I hope you understand these things, my dear friends. So now here is you can see, so angle A is what? Angle A is angle 1 plus angle 2, so this will become angle 1 plus angle 2. Angle B is what? Angle B is angle 3 plus angle 4. Angle C is what? Angle C is angle 7 plus angle 8 plus, and angle D is angle 5 plus angle 6. This is equals to 360 degree. Got it? So now from this we know that here is, you can write this is angle 1 plus this is angle 2 plus, here is we can write we know that angle 3 is equals to angle 7. Angle 3 is equals to angle 7. So here from this angle 3 is equals to angle 7. Okay, so here we can write angle 7 in place of angle 3. Okay, we can write from equation 1, 2nd, 3rd and 4th. From equation 1st, 2nd and 3rd we know that angle 3 is equals to angle 7, angle 4 is equals to angle 2, angle 6 is equals to angle 1, angle 5 is equals to angle 8. So this will become, here is we can write angle 7 in place of angle 3 and we can write angle 2 in place of angle 4 plus this is angle 7 plus this is angle 8 plus this is we can write angle 8 in place of angle 5. Okay, plus we can write angle 1 in place of angle 6. This is equals to 360 degree. So this will become twice of angle 1 plus angle 2 plus angle 7 plus angle 8. This is equals to 360 degree. Okay, so this will become angle 1 plus angle 2 plus angle 7 plus angle 8. This is equals to, if we divide 360 by 2 we get 180 degree. So this will become, here is angle 1 plus angle 2 is what? Angle A. So this is angle A plus angle 7 plus angle 8 is what? Okay, angle C. It means angle A plus angle C is equals to 180 degree. 180 degree. Similarly, we can also find, we can write angle ABC means angle B plus angle ADC means this angle D is equals to 180 degree. Okay, so we can write here as hence proof. Okay, my dear friends, so this is the proof of this theorem. Now let's see the next theorem, which is, now here is in this, if the sum of a pair of opposite angles of a quadrilateral is 180 degree. If the sum of the pair of opposite angle, it means if the sum of angle A plus angle D and angle C plus angle D, which is equals to 180 degree, then we can say that the quadrilateral is what? Cyclic quadrilateral. Okay. Yes, so now here is, first of all we have to write the given part. So here is, okay, yeah, so we have ABCD, which is a quadrilateral. ABCD is a quadrilateral such that here is angle BAC plus angle BDC. This is equals to what? This is equals to 180 degree. Okay, and angle ABD plus angle DCA, which is equals to 180 degree. Okay, and here is, we have to prove that ABCD is a cyclic quadrilateral. Okay, my dear friends, so here is, let's see the proof of this theorem. Okay, yes, so now proof of this theorem. Okay, yes, so now here is, we know that A, B and C, these 3 points are what? These 3 points are non-collinear, and we know that one circle passes through 3 non-collinear points. Okay, now let us draw a circle. Yeah, so let us suppose this is circle C1 with center O. Okay, now let us assume D does not lie on the circle. Let's suppose D lie outside the circle. Here is, we are considering now ABC dash is, we are supposing that ABC dash is a cyclic quadrilateral. This is a cyclic quadrilateral. This ABC dash is a cyclic quadrilateral. Okay, and here is angle BAC plus angle BD dash C is equals to 180 degree. Opposite angles in this cyclic quadrilateral are supplementary. Okay, but given is angle BAC plus angle BDC is equals to 180 degree. Okay, so here is, thus from these two equations we can say that angle BD dash C is equals to angle BDC, means these two angles are equal. Let's suppose this is equation number 1. Okay, now in triangle BDD dash. Okay, so here is, in this triangle BDD dash. Okay, so this angle is what? This angle BD dash C, means this angle is what? This is the exterior angle. So by the exterior angle property we can write angle BD dash C is equals to, this is equals to what? Angle BDD dash, means this angle, plus angle DBD dash means this angle. So here we have angle BDD dash plus angle DBD dash. So this is what? This is by exterior angle property, exterior angle property. Okay, yes. So now here is angle BD dash C is equals to angle. We can write here is, you can see in the previous, we can write BDD dash as a BDC. Okay, we can write angle BDC. Okay, so here is angle BDC plus angle DBD dash. Okay, so this will become angle, we can write angle BDC in place of angle BD dash C from equation 1, from this equation. Okay, got it? And this is equals to angle BDC plus angle DBD dash. Okay, so now we can write from equation 1 this part. Okay, so if we shift this angle to the LHS, so we get angle BDC minus angle BDC. This is equals to angle DBD dash. Okay, so this will be cancelled. So angle DBD dash is equals to 0, means this angle DBD dash, means this angle becomes 0. Okay, so we can say that D dash and D coincides. Okay, thus we can say our assumption was wrong. Our assumption was wrong. Okay, so we can say that point D lies on circle C1, means lie on circle C1, means this point D lies on circle C1. Hence we can say that ABCD is a cyclic quadrilateral, because we assume that ABD dash C is what, cyclic quadrilateral, but here is we prove that D and D dash, these 2 points coincide. It means we can say that D dash is the same as D, so we can say ABDC is the cyclic quadrilateral, and we can say hence proof. Okay, my dear friends, I hope you understand these things. So now let's solve the problems. Yes, so now here is, so the question number 1 is, in the figure, angle PQR, here is angle PQR is 100 degree, where P, Q and R are points on a circle. P, Q and R are the points on the circle with center O, and we have to find angle OPR. This is OPR, means we have to find this angle. Okay, now my dear friends, here is, we know that PR is what? PR is chord. Okay, PR is the chord of the circle. Got it? And now let's mark point S on the major arc of the circle. Like this. Okay, so here is, if we join these, we get PQRS, which is what? Which is the cyclic quadrilateral. Okay, so here we can write, we know that PQRS is cyclic quadrilateral, because these points are on the circle. Okay, now here is, and we know that in cyclic quadrilateral the sum of opposite angles is what? 180 degrees. So angle Q plus angle S is equals to 180 degrees. So angle S is what? 180 degree minus angle Q is this 100 degree. So 180 minus 100. So we get 80 degrees. So angle S is 180 degree. Okay, my dear friends, I hope you understand these things. And arc PQR, this arc PQR, this arc here is by the theorem. We know that angle subtended by arc at the center, which is this, at the center, is double the angle subtended by it at any other point. Okay, so here is, we can write arc PQR subtends angle POR at the center, at center of circle, and angle PSR on point S. Okay, yes, so now here is, we can write, so angle POR means this angle POR, this angle is equals to twice of angle PSR. We can write by theorem tan point 8, by theorem tan point 8, because angle subtended by arc at the center is double the angle subtended by it at any other point. Okay, yes, so now angle POR is equals to 2 into angle PSR is what? Angle PSR is 80 degree, is 80 degree. So this will become 160 degree. So angle POR is 160 degree. POR is 160 degree. Okay. Now in triangle OPR, here is, we know that OP is equals to OR, because these two sides are what? These two sides are radius. Okay, so here we can write in triangle OPR, OP is equals to OR. Okay, these are the radii of the same circle, radius of the same circle, and we know that the radius of the same circle are what? Equal. So here from this we can write, since angle OPR means this angle is equals to angle ORP means this angle. So angle OPR is equals to angle ORP. Okay, because angles opposite to equal sides are equal. Angles opposite to equal sides are equal. Equal sides are equal. Okay, now also in triangle OPR, by angle sum property we can write angle OPR plus angle ORP plus angle POR is equals to 180 degree, and here is angle OPR is equals to angle ORP, so we can write here is twice of angle OPR plus angle POR. Angle POR is, we know that this is 160 degrees, so this is 160 is equals to 180 degree. So from this we can write as twice of angle OPR is equals to 180 minus 160, so we get 20 degree. Okay, and angle OPR is equals to 20 degree divided by 2, we get 10 degree. Okay, my dear friends, so angle OPR is what? OPR is 10 degree. OPR is what? 10 degree. I hope, my dear friends, you understand these things. So this is the solution of this question. Okay, yes, so now in the next question, in figure A, B, C and D are 4 points on a circle. There are 4 points on a circle A, B, C and D. AC and BD intersect at point E, means AC and BD, these two lines intersect at point E, such that angle BEC is 130 degree. Okay, and angle ECD means this angle is 20 degree. Find BAC, we have to find angle BAC. Okay, so here is, we know that since BD is a straight line, okay, so since BD is a straight line, so we can write angle BEC, plus angle CED, means this angle is equals to 180 degree, because they are linear pair, and we know that the sum of linear pair is what, 180 degree. Okay, and here is angle BEC is, we know that this is 130 degree, plus we have to find angle CED, which is equals to 180 degree. So here is, from this we can easily find, so angle CED is equals to 180 minus 130, so we get 50 degree, so this angle is 50 degree, so angle CED is 50 degree. Okay, my dear friends, I hope you understand these things. Yes, so now in triangle DEC, here is, we are talking about this triangle DEC. In this triangle, we know that this angle, and we have to find this angle. So by angle sum property, we can easily find angle EDC. Okay, so now here is, in triangle DEC, so angle DEC plus angle EDC plus angle ECD, this is equals to 180 degree. Okay, and here is angle DEC is 50 degree, plus angle EDC, we have to find angle EDC, plus angle ECD is 20 degree, this is given, so this is equals to 180 degree. So from this we can easily find angle EDC is 180 degree minus 70 degree. So here we get angle EDC is 110 degree. So this is what, 110 degree. Okay, my dear friends, so now here is, we can see that segment BADCB, this segment BADCB, here is, you can see angle BAC, this angle, and angle BDC, means this angle, are in the same segment and they must be equal. So we can write for segment BADCB, angle BAC and angle BDC are in the same segment, so by the theorem we can say that they must be equal, got it? So angle BAC is equals to angle BDC, means angle BAC is equals to angle BDC. So we can write the reason that angles in the same segment by theorem 10.9. So angle in the same segments are equal. Are equal. Okay, so we know that angle BDC is what, 110 degree. So here is angle BAC is 110 degree, 110 degree. Okay, my dear friends, I hope you understand these things. So this is the answer of this question. Okay, yes, so the next question here is, ABCD is a cyclic quadrilateral, here you can see, whose diagonals intersect at point E. If angle DBC, this angle is 70 degree, angle BAC is 30 degree, angle BAC, this is 30 degree. Then we have to find angle BCD. Angle BCD means we have to find this angle. Got it? And further, if AB is equals to BC, means this AB is equals to BC, then we have to find angle ECD, means this angle. Then we have to find angle ECD. Okay, so now let's start. So for segment here is DC, B, means for this segment. Here is, you can see, for this segment angle CBD, and means we are talking about this angle, and angle CAD means this angle. These two angles are in the same segment, so they must be equal. So we can write for segment DCBAD, here is angle CBD and angle CAD are in the same segment, so they must be equal, okay. So we can write angle CAD is equals to angle CBD, and we know that angle CBD is what, 70 degrees, so angle CAD is also 70 degrees, so angle CAD is equals to 70 degree. Okay, my dear friends, I hope you get this point. So these two angles are equal by what? By angles in the same segment are equal. By the theorem, angle in the same segments are equal. Okay, now here is, now angle BAD, we can write angle BAD is equals to angle BAC, okay, plus angle CAD means this angle plus this angle, okay. So here is angle BAD is equals to angle BAC plus angle CAD. Now we know that angle BAC is 30 degree and angle CAD is 70 degree. So this is equals to 30 degree plus 70 degree. So we get angle BAD is equals to what? 100 degree, is equals to what? 100 degree. Okay, my dear friends, I hope you get this point. Now here is, now in cyclic quadrilateral, now ABCD is a cyclic quadrilateral, we know that, okay, and we know that sum of opposite angles is 180 degrees. So angle BCD means this angle plus angle, here is angle BAD means this angle, is equals to 180 degree. So now we know that ABCD is a cyclic quadrilateral, So here angle BCD plus angle BAD is equals to 180 degree, okay, and angle BCD plus BAD is what? 100 degree, is equals to 180 degree. So angle BCD is equals to 180 minus 100, so we get angle BCD is 80 degree. So angle BCD is what? 80 degree, means this angle. So this is our first answer. Okay, now let's find the second answer. Also, if AB is equals to BC, okay, so we can say that angle BCA means this angle is equals to this angle, because angles opposite to equal sides are equal. Okay, so my dear friends, so we can write in triangle ABC, AB is equals to BC. This is given in the question. Okay, so we can write, so angle BCA is equals to angle BAC, because we know that angles opposite to equal sides are equal. Okay, so now here is angle BCA will become 30 degree because angle BAC is 30 degree. So angle BCA is 30 degree. Is what? Is 30 degree. Now we have to find what? We have to find, here is, you can see, we have to find angle ECD, means we have to find this angle. So here is, we know that angle BCA means this angle is, yes, 30 degree. Okay, and also angle BCD. Which angle? Angle BCD is equals to what? Angle BCA means this angle plus this angle plus angle, you can write ECD. So angle BCD is what? Angle BCD is 80 degree is equals to, from this here, angle BCD is 80 degree. Okay, and angle BCA, this is 30 degree. Here we can write, okay, this is 30 degree plus angle ECD we have to find. So now from this, angle ECD is equals to 80 minus 30, we get 50 degree. So angle ECD is what? 50 degree. I hope, my dear friend, you understand these things. So this is our answer of this question. This is our answer of this question. Okay? Yes. So now the next question here is, now if a line intersects two concentric circles. Okay, now here you can see this line L intersect two concentric circle, which is C1 and C2. Okay, with center O at A, B, C and D, at A, B, C and D, and prove that AB is equals to CD, and we have to prove AB is equals to CD. Now here is, first of all, we have to write the given part. So the given part is what? So we have, okay, so we have two concentric circle. Now what is concentric circle? We already know that. Two concentric circles. So those circles which having the common center. Okay, so in C1 and C2 having the common center O. Okay, two concentric circle with center O. Okay, and we have a line, and a line intersects this circle at A, B, C and D points. Okay, A, B, C and D point, and we have to prove, here is, we have to prove, you can see AB is equals to CD. AB is equals to CD. Yes, so now let's start the proof of this problem. So here is, we are going to start. So now let two circle, we have two circles C1 and C2, and line we have L. Okay, so we draw OP, we have to draw OP line which is perpendicular to line L. Okay, so we draw OP which is perpendicular to L. Okay, so now in circle C1, we know that OP is perpendicular to BC, as OP is perpendicular to L. OP is perpendicular to L. Okay, so we can say that OP bisects BC, means this line OP bisect BC, because perpendicular draw from the center of a circle to a chord bisect the chord. Okay, with the help of theorem we can say that. So that is, we can write as BP is equals to CP. Okay, so let's suppose this is equation number 1. Okay, similarly in circle C2, here is, we know that OP is perpendicular to AD, because OP is perpendicular to line L, so we can say that OP is also perpendicular to AD, and so that we can say that, so OP bisects AD, means this OP bisects AD, so we can say that, so AP is equals to DP, means this line is equals to this line. Let's suppose this is equation number 2. The reason is same. Perpendicular draw from center of a circle to a chord bisect the chord. Okay, by the theorem. Now, yes, from 1 and 2, we are subtracting equation 2 and 1. Okay, so we can write that subtracting equation 2 and 1. Like we have to subtract equation 2 from equation 1. So now here is, okay, so this will like here you can see this will become AP minus BP, which is equals to DP minus CP. So we can write AP minus BP is equals to DP minus CP. Okay, so this will become AB is equals to CD. This will become AB is equals to CD, means this line is equals to this line, and we can say hence proof. So my dear friends, I hope you understand these things. So this is enough for today, and we will meet in the next lecture with the next amazing topic. So thank you very much for listening me, and take care and goodbye.